Okay, here we go. Sequences and series, day 3. For my students in 2024, we're going to have fun in this packet and X out quite a few of the problems. From there on out, this is always going to be a short lesson. So here we go. The reason why we're going to X out things is that there are different ways to define recursive sequences, and this one that you're seeing here is the way that our book, and we don't even use the book anymore. Some people use this way, but most people use the opposite way, which is on Delta Math. So we are going to just stick to the one that the majority of people use to define a recursive sequence, and we're just going to X through that. So let's see, let's keep looking. We are going to keep going with this. So here we've got a sequence, and if we wanted to define this, could we define it using nth term, right? What's going on? Well, it looks like our D is 4, right? Everything's going up by 4. So if we wanted to define it, now, let's just not do that. But if we wanted to, right, it'd be a sub n equals 4n, and what would our zeroth be? -1, right? So that's one way to define it. But sometimes you're going to be asked to define things recursively, because every now and then, doing a recursive definition makes more sense. So here we go. What is this recursive thing? So the first thing that we're going to do, and you're going to love this, is we're going to say a sub 1 equals, and we're going to write whatever a sub 1 is. That is actually part of our definition, okay? And then we're going to say, and if you want to find any other term, so any other term is a sub n, right? If n were 2, that'd be our second term, and 3, that's our third term. If you want to find that, what you do is you look back to the term before it, and what do you think we're going to do? If we wanted to know how to get our second term, 7, we'd look back at 3, and what would we add to it? We'd add 4. Guess what? We're done. This is our recursive definition, okay? And so does that make sense? It's like, okay, let's think about how we would use this. Like, let's say we wanted to know a sub 1 equals 3, and hey, do you know the 100th term? Now, this definition would just be terrible to find the 100th term, because look what we have to do. We'd say, sure, now look back at the 99th term and add 4 to it. Well, we don't know the 99th term, so it's limited. It is limited when you want to know an nth term way out there, but it's kind of fun to do it if you're just looking at terms that are closer. Like, for instance, if we wanted to know, and we just already kind of did that, if we wanted to know our second term, well, a sub n minus 1 means look at a sub 1 and add 4 to it. Well, we already know a sub 1, right? Because it gave it to us. That's 3. So 3 plus 4 is 7. And wouldn't you know it, that's 7. Now that we know a sub 2, could we find a sub 3? Sure. A sub 3 would be look back at a sub 2 and add 4 to it. Well, thank goodness we already know a sub 2 is 7. So 7 plus 4 is 11. So you can see it's kind of a fun way to define a sequence, but it's not anywhere near as useful as an nth term definition. So let's see what else we've got. See if we can cross through anything. Oh gosh, look, here's the a sub k plus 1. That's another way, but we are not doing that. We are putting a big X on that. That's really fun, isn't it? Just X out those problems. Same thing, we're going to X this out because we now define it, and I think an easier way. All right, ooh, that's blurry. So sometimes you'll see a recursive sequence question asked this way. So this is what we've been talking about. This is how you're going to see it on Delta Math, and this is how you're going to see it on our test. So here's a definition, right? We've got a sub 1 equals 6, and a sub n equals a sub n minus 1 plus 1. So what do we think this is going to look like? What's my first term? My first term is going to be 6. Okay, what's my second term? Well, to find the second term, a sub 2, we look back at a sub 1, and we add 1. So if a sub 1 is 6, we add 1, that's 7. What do you think this is going to look like? This recursive definition is telling us every term is 1 more than the term before it, right? If you want to look at this part of it, that's what this says. It says every term is equal to the term before it plus 1. All right, so I think this is going to be an easy lesson for you all. The Delta Math ones are fun. They look like this. Oh, look, I already answered this. So, oops, you didn't see that, did you? All right, so this is a typical Delta Math question. and it just asks you to go ahead and define it recursively. So what we're going to do is we're going to say, okay, let's find a better color. So my first term is 19. Isn't that an awesome thing? Like, that's easy. And then we're going to go ahead and say, all right, you want to find any term after that, any a sub n? Well, look to the term before it, a sub n plus 1. And then what are we going to do? What's going on from 19 to 21? What's going on from 21 to 23, right? We're adding 2. So bam, we're done. All right, so we are defining sequences in a different way. We're defining them recursively. All right, so let's look at this. So this one's a little bit tougher. I think on Delta Math, these are multiple choice ones because this one's not going to come to us pretty easily or super easily. So let's say we've got a sub 1 equals 8, and now we want to figure out how is a sub n related to, let's see if I can erase with my finger. You know I hate this board. All right, there's the eraser. All right, so now we're going to look at the relationship. So let's see, we could say what? 8 plus 13, right, is 21. 21 plus 39 is 60. We're like, uh-oh. This isn't arithmetic, so it's not going to be as easy to define recursively. It's not geometric either, right? We don't have a common ratio, do we? And so that's where we want to stop and think. And if you want to pause the video and really think about the relationship between 8 and 21 and 6, I had to definitely take some time before I did this video to think, wait a minute, what is going on? So what's going on? Go ahead and pause it, and then you can come back. All right. Did you really pause and think? You better have. So let's do this. What I noticed is like, ooh, first I was like, how about 8 times 2 plus 5? It's like, okay, that sounded good. That got me to 21, right? But 21 times 2 plus 5, oh, didn't get me to 60. And then I started messing around with what about times 3? Because I could tell multiplication is going on here. It's not going up fast enough for it to be a multiplier, like an exponential. It's not a geometric. So I thought, well, what about 3? So 3 times 8 is 24. Ooh, super close, right? 3 times 8 is 24. And then minus 3 gives me my 21. Let's see if that's true for 21. 3 times 21 is 63. Minus 3, bingo, that's 60. So what we're going to do for our definition is 3 times a sub n minus 1. So 3 times the term before it plus 3, and we're done. Like I said, these harder ones with Delta Math, I'm pretty darn sure they're multiple choice ones, and so you can kind of do it that way. All right, so that's fun. And then this seems like, what are these factorials? So sometimes when we're trying to define a sequence, like do an nth term definition, and it's not arithmetic and it's not geometric, it is just something that we may have to use factorials for, and use factorials in calculus. So here goes. So it's like 5 factorial. Is that just a really excited 5? 5, I'm 5. All right. Factorial means this. 5 factorial means 5. Oh, I don't want to be writing in yellow, do I? 5 times 4 times 3 times 2 times 1. We stop at 1. Otherwise, we just would keep writing times 0 times negative 1, and we don't want to do that. So 5 times 4 times 3 times 2 times 1, that is what 5 factorial means. I'm going to put the fraction line here, and then I'm going to look, and first I'm going to make sure that we are still going. Okay, I'm almost done. And then 3 factorial is 3 times 2 times 1. But watch where I'm going to write that. I'm going to write that here. 3 times 2 times 1. Why do you think that is? Well, I'm in a fraction, and I can go ahead. All of these are just being multiplied together. So I'm allowed to go 3's cancel out, 2's cancel out, 1's cancel out. And 5 times 4 is 20, and that's my answer. Now, you're going to see these on the test because factorials are important. We just see them for like a blink of an eye in this class, but if you do calculus, you're going to use them more. Now, you do have a factorial button on your yellow calculator, but the problem is sometimes factorials get to be so huge that it gives you, an answer in scientific notation, which is sometimes hard to read. So we're going to do shortcuts instead. So once again, 39 factorial. Do you think we're really going to write 39 times 38 times 37? Oops, 37 times 36 and keep going all the way to 1? No, we have better things to do, right? Ooh, I didn't let me write that. I'm going to do dot, dot, dot. And the reason why I'm going to do that is that look what is underneath. 36 factorial, which is 36 times 35 times dot, 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 dot. All right. So the nice thing about this is the 36's cancel out, the 35's cancel out, and we don't see the numbers, but right, the 34's, the 33's, the 32's, all those cancel out. And what do we have left? 39 times 38 times 37. Do I have a calculator? Our calculator can handle this one, but my brain can't. I've definitely got to. So we've got 39 times 38 times 37. All right, so that's 5. Once again, I'm in yellow. Can you see that? Let's switch. 5, 4, 8, 3, 4. All right, let's do one last one. 2034, once again, we are not going to go all the way to, let me erase this part. We're not going to go all the way to 1. That would take us all day, maybe even more than a day. All right, so let's see. Let's do the same idea, right, of just starting here and seeing how far we need to go. I'm going to go, can we be okay with dot, dot, dot here? I mean, yes, could I do a 2031? Sure, but you know what? We're going to do 2032. Sometimes people would say factorial here, but the dot, 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 we understand what that means. So that means the 2032 factorial. So the 2032 cancels out with 2032. 2031, 2031, you get it, all the way down to 1. Those are all gone. And then let's pick up our calculator and do the 2034 times the 2033, and that's going to be 413. Oops, nope. Undo. 413, 5122. Where are those? There we go. All right. I think that's it. So this is going to be an easy one, an easy day. I would take today, and once you're done with your Delta Math, maybe go back in your notes and practice. Just kind of like maybe get a marker board and see if you can redo some of the problems we did during class with our notes, just to keep you going with the geometric and the arithmetic and all the sums and series and all that stuff. All right, thanks for joining me. I will see you in class. Just